In problem 52, we have a truck which is carrying a giant pipe. This giant pipe is restricted with these two blocks, A and B. And also it is sitting on the floor on this truck, the trailer. And at this moment, the truck is turning to the left, and the radius of the curvature or the radius of the turning is rho. And the question is, what is the maximum velocity that this truck can have without this pipe to roll over? So let's assume the truck is going with that maximum velocity. So if it goes with that maximum velocity, if it goes a little bit more than that, then all the pipe is gonna roll over, right? In that boundary or close to that velocity, um, uh, the normal force or the interaction of the pipe is going to lose its interaction with the floor of this trailer, and also it's going to lose its contact with this block as well. So the only force we are going to have is going to be force from B. So if I want to draw the free body diagram of this pipe while it's going with that maximum velocity, we are going to have mg, and also we are going to have a force at B. Here I'm assuming the force is going to go toward the center, but why? I'm going to let you to think about that. So we are going to have a reaction force at B, and also we are going to have mg. There is no force between the pipe and the floor because we are assuming it's about to roll over. And also it is about to lose its contact with the block A, so there is no force here. So I would suggest to stop this video and think about the rest of it for a few minutes, then see the rest of it. So again, everything is moving on a circle. If you look at everything from the top, and let's say this is the truck is moving on a circle with the radius of rho. And because of that, we are going to use tangential normal coordinate again. And also you can use polar coordinate as well, but normal tangential is more handy. And also we have this free body diagram. And we are assuming it is moving with that maximum velocity, which we are going to call it V here. And also I'm going to use this direction as well. Let's call it Z again, because I'm going to write equilibrium equation in that direction to find a relationship between B and gravitational force. Let's say this angle is equal to alpha, which we are going to find it in terms of h. And let's actually do that because I need this angle. If you look at this carefully, look at this triangle, cosine of alpha is going to be r minus h. Cosine of alpha is going to be this distance, which is r minus h, the height of this block, divided by the radius, which is r. So alpha is going to be equal to cosine inverse of r minus h divided by r. You can put the numbers to find this. If you put the numbers, the given numbers, this angle is going to be 29 degrees. So after finding this, now I can write the Newton equation in the z direction. Sum of the forces in the z direction is equal to 0. So B times cosine of alpha is going to be equal to mg. So from here we can find B. Force B is going to be mg divided by cosine of alpha. And also I'm going to write some of the forces in the normal direction to find the relationship between that angular velocity, which comes from the maximum speed, and also B, which is related to mg. Let's see what happens. Sum of the forces in the normal direction is equal to mass times acceleration in the normal direction, which we know acceleration in the normal direction is equal to velocity squared divided by rho. And also, the only force we have in the normal direction, which is this direction, is component of b times sine of alpha. So b times sine of alpha is going to be equal to m times v squared divided by rho. And we know b is equal to mg divided by cosine of theta. So if you replace it there, we are going to have b times, mg divided by cosine of theta times sine of theta is going to be mg times tangent of theta, tangent of alpha, is equal to m v squared divided by rho. M is going to cancel out. From here, we can find the velocity. Velocity, which is that maximum velocity, let's call it m v max, is going to be square root of rho g tangent of alpha. So this is the maximum velocity that the car can have without this pipe to roll over. And also we have some numbers for h and rho. If you put those numbers, the maximum velocity is going to turn out to be 18.05 meter per second, or 65.0 kilometer per hour.